This is CPM Precalculus, Chapter 3, number 46. So use your knowledge of sigma notation to answer the following questions. So part A says just to expand this expression that has sigma notation. Alright, so I'm going to say equals, right, because it does equal this. We start at I is 3, so I'm going to plug in I is 3. So 4 times 3 cubed minus 1. The next term, we're going to increment I, so it goes from 3 to 4, and we're going to plus, right, because sigma means to add, right, means to add every term. So now we're going to have I is 4. And we're going to add when I is 5. Then we're going to add when I is 6. Right? So this is all of the terms here, and this is expanded. Okay, I don't want to go ahead and compute the entire sum. Okay, at most I can go ahead and compute each one of these. If I wanted, I could. Right? I could go ahead and say this is equal to 4 times 3 cubed is 27 times 4, which is 108. So I could do 108 minus 1 is 107. I could do this much if I wanted. 4 times 4 cubed. Well, 4 times 4 is 16, times 4 is 64, times 4 again is 256, minus 1 is 255, plus 5 times 5 is 25, times 5 is 75, times 4 times 75 is, 4 times, not 75, sorry, 5 times 5 is 25, times 5 is 125, that sounds more like it. 125 times 4 is 500, minus 1 is 499, plus 6 times 6 is 36, times 6, oh, now I'm not sure, what's 6, 36 times 6 is 216, yeah, I should have known that, times 4 is 864, minus 1 is 863. So I could go ahead and write it like this if I want, and that would still be expanded form. So either one of these is okay. But if I add them together, then that's solving and computing. So I'm not going to do that. But if I did, that would be, I think, 1,724, right? But let's not do that. This is just expand. So let's leave it in expanded form. Part B says to write the following using sigma notation. All right. So what do I see here? Okay, so I'm going to put equals, right, because I'm going to write what it equals to in sigma notation. I'm going to start with k being, I don't know, 0. You could start with any number you want. If this is 0, if that's 0, then that's the term 0, term 1, term 2, term 3, term 4. So I'm going from k 0 to 4. What stays the same every time is 0.4 times, and I'm going to do 0.4 times, we're going to do 1 over something, right? So it's going to be 0.4 times 1 over something. That something, as we see, is going to be a linear series, right? Because we're adding 0.4 every time, right? The linear series, with when we're adding 0.4 every time, right? To get to the next number, that means my slope is 0.4 for the y is equal to mx plus b line linear series, right? So actually I have it in the form with my variable being k, so I'm going to write it y is equal to 0.4k plus b. At k is equal to the first number, that's 0, y is equal to my first output, that's 2. So I have 0.4 times k, which is 0, plus b equals 2. So that shows b is equal to 2. So my linear series is going to be y is 0.4k plus 2. I'm just plugging in b is 2. So I plug this back in here, and I write 0.4k plus 2. And this right here is my linear series. Represented, this is my expression, the whole expression represented using sigma notation. Okay? And remember, there will be an infinite number of solutions because you can start at whatever number you want. And in fact, there will be different expressions that you could probably find to represent this as well. So that's going to end for us CPM Precalculus Chapter 3, number 46.